In lesson number 2, we're going to have a look at vSphere's virtualization of resources. And that is, how does ESXi, how does vSphere interact with CPU, memory, networking, and storage, right? Basic concepts of this. Okay. So we have to understand now that virtual machines that we see up here are applications running on an ESXi host. And when we create these virtual machines, we essentially are building a virtual motherboard. Okay? A motherboard that exists in any server, any desktop PC, any laptop. One that has CPU on it, has memory on it, has a storage controller with actual storage attached to it, whether it be hard drives or NVMe devices or SSDs. We've got a network port on it, right? We've got NICs, multiple NICs in some cases. Okay. Now, when we build these virtual machines, we are going to assign to these virtual machines a portion of the resources that the ESXi host has access to. That is, for all of the CPU that exists on your hosts, right, a portion of it will be assigned to your virtual machine. For all of the memory that exists in your ESXi hosts, a portion of it will be assigned to the virtual machine. That for all of the storage that your hosts have access to, a portion of that storage in the form of a virtual disk will be assigned to your virtual machine. That for all of the many network ports that your ESXi host has access to, right, at least one of those, through the concept of a virtual switch, will be assigned to your virtual machine. Now, when it comes to the physical architecture, of course, we have an operating system like Windows or Linux or Mac OS, for example, right, that has access to the entire complement of the hardware running on a host here. Okay? So the application, of course, is assigned resources by the operating system, and those resources are derived from that physical architecture. But in the case of a virtual architecture, ESXi becomes a new layer that sits between the virtual machine and its guest OS and applications and the physical hardware on the bottom. So that when we build a virtual machine, we assign to it its own complement of virtual CPU, of virtual memory, of virtual disk, and a virtual network port. Okay, that are all derived from and managed by the ESXi hypervisor, right? So we derive it from the physical architecture, and this ESXi operating system manages the allocation of physical resources between the physical hardware and the virtual machines. Once the virtual machine has access to the resource, the guest operating system allocates that virtual resource to the applications running within that virtual machine. So it's just really a new layer here that sits between your applications and the physical hardware. So ESXi is going to manage the sharing of those resources between all of the virtual machines that are running on the ESXi host. When we build that virtual machine, we'll assign a certain number of virtual CPUs, and that number of virtual CPUs in every VM must be less than or equal to the number of physical cores, or in the case of hyper-threading, you can kind of double that, but we'll talk about that a little bit later. Okay. We'll assign less than or equal to the number of physical CPUs to that virtual machine, to any single virtual machine. The same holds true for RAM. A portion of this RAM will be allocated to each virtual machine. Okay? It is possible that we create so many virtual machines on a host whose aggregate sum of resources that we allocate to it are greater than the total amount of physical resources available on the host. That concept we call overcommitting. It means that, for example, imagine I have, say, 24 cores on my physical host. I can create virtual machines who all together utilizes well more than 24 virtual CPUs. Let's talk a little bit more in detail about that right here. So when it comes to CPU virtualization, okay, we know that in a physical architecture, the applications have access to all of the CPU, right? The operating system says, okay, application, you just make your requests. I'll go and find a physical resource for you and allocate that physical resource to you. In the virtual architecture, don't forget that the underlying application here is not the app here in the guest OS. The app is the virtual machine itself. So when I provision a virtual machine with a certain number of virtual CPUs, that virtual CPU itself is actually an application running on the hypervisor. So if the guest OS says, hey, I need some CPU resources for this application, then this guest OS says, oh, here's a CPU. Let me schedule a thread on your behalf on this virtual CPU. ESXi then intercepts that request and finds some physical resource down here for that CPU thread to be executed upon. When we have two virtual CPUs running in a virtual machine, then ESXi must find two physical cores on which to allocate those resources. When we have four virtual CPUs, ESXi must find four physical cores on which to allocate those resources and execute those threads. Okay? That's why we can't have more in any single VM than we have on the physical host. If a virtual machine said, I have 8 virtual CPUs, please allocate those resources onto the only 4 cores that you have, sorry, that doesn't work. But in this case, I have a total of 7 virtual CPUs. And as long as no single virtual machine is 100% of the time occupying all of the CPUs, then we've got plenty of resources to go around where this VM gets its turn on the CPUs, this VM gets its turn on the CPUs, and this VM gets its turn on one of the 4 cores that we have available here. This overcommitment of resources needs to be managed carefully. We can't go too far. Otherwise, we may have a virtual machine that says, hey, please schedule my CPU threads on physical cores down here. But those physical cores may be scheduled for other virtual machines. And this virtual machine that's waiting for a CPU to become available will experience a performance degradation. So we have to be very careful about how we allocate these resources. But because virtual machines don't typically utilize 100% of their CPU resources, then we're just fine in over-allocating CPU. Sometimes we'll call this a ratio of over-allocation. How many virtual CPUs can I establish and run in my environment for every physical core? How many virtual CPUs per physical core can I have? Well, the answer to that is, like most answers at VMware, well, it depends. It depends on the requirements of the applications running in the virtual machine. If I have an application that needs very little CPU, and say I give that virtual machine 2 CPUs, maybe it's only scheduled on physical cores, say 5% of the time. 5% of the time, if I've got lots of VMs like that, you would think I could do a 20-to-1 virtual to physical ratio. Well, 21-to-1 is a little bit high. How often are we only utilizing a CPU 5% of the time? So you have to look at the applications running in your infrastructure to determine what kind of overcommitment ratio you would like to have in your environment. Now, when it comes to memory, we can make the same argument. Of course, in a physical architecture, applications need a certain amount of RAM, operating systems need a certain amount of RAM to be able to act efficiently, to avoid things like having to swap out to disk, and things like that. So we build our hosts with a whole bunch of memory, okay? And in the physical architecture, all of that memory is managed by the underlying operating system and then allocated to the applications that run within that operating system. In the virtual world, all of the memory of the ESXi host is managed by ESXi itself and then allocated to the virtual machines based on your configuration of each virtual machine. So when I build a virtual machine, like I establish a certain number of virtual CPUs, I establish a certain amount of virtual memory. 1 gigs, 2 gigs, 512 megs, 2 terabytes, whatever it might be based on the application requirements. You as a vSphere administrator must know something then about those application requirements. It's really important. I don't want to blanketly say every single virtual machine is going to get 8 gigs of RAM. Some will need far less, some will need far more based on those applications. Now, similarly to the way that we can overcommit CPU, but maybe not to quite such an extent, we can also overallocate memory. ESXi needs a minimum of 4 gigs of RAM just for ESXi itself. If you want to run virtual machines, and of course we want to run virtual machines, VMware actually recommends a minimum of 8 gigs of RAM. So let's say we've established an ESXi host with the minimum system requirements to run virtual machines in this environment. And now I'm going to power on my virtual machines. Everybody's fine, right? This virtual machine gets a maximum of 1 gig of RAM. This virtual machine gets a maximum of 2 gigs of RAM. This virtual machine gets a maximum of 8 gigs of RAM. Okay? That memory isn't automatically allocated to the virtual machine when it's powered on, unless we do a couple of other things with the configuration of that virtual machine. So ESXi will make best effort to give a virtual machine what it asks for, but no more than we've configured it for. So as our operating system powers on, say let's look at this 1 gig virtual machine. It's kernel loads and it needs some memory for that. And say it's a small Linux VM and it doesn't even need a full gig of RAM. Well, ESXi will only allocate or apportion to it the memory that it asks for when it asks for it. It will never exceed more than 1 gig. And if this were true for all 3 of these VMs, say they were all running this little mini operating system, and they all only needed 512 megs of RAM when they booted, then even though we've allocated more RAM than we have on this physical host, where we said we only actually had 8 gigs of RAM, everybody should be fine. But what happens if we start launching applications in these virtual machines, and all of a sudden, this guest OS needs to allocate a full 8 gigs of RAM to this application, and there isn't a full 8 gigs available down here? Well, that's when we start hitting contention for memory. And there are some techniques that we have that we can use, like many operating systems, like swapping out to disk, for example, to make sure that we are at least able to maintain these virtual machines in some sort of state of relative low or high levels of performance. So do I want to power on 11 gigs worth of virtual machines for memory on a host that has 8 gigs of RAM? Well, maybe, maybe not. It depends on the applications running in these VMs, of course. Okay? I'm certainly not going to go to a 20-to-1 ratio like I might with CPU. With CPU, VMware for the most part recommends not exceeding about a 10-to-1 ratio, and in most cases it's far less than that. For memory, VMware recommends no more than a 2-to-1 ratio, 2 gigs of virtual memory across all the VMs for every 1 gig of physical memory. Now I know that in the environments I've run, my virtual machines typically utilize more than 50% of their RAM. So in my case, a 2-to-1 ratio is even going to be too much, too high. Maybe I'll over-allocate by 10 or 15 or 20%. Maybe for memory, if it tends to be a bottleneck in my environment, I won't over-allocate at all. When we come back, we'll have a look at networking and storage.